If I am given 2 points, how can I write an equation for the line that goes through them? Thinking about that slope-intercept form, y equals mx plus b, I need to find the slope and I need to find the y-intercept. So I can graph this if that's available to me. I can put it on graph paper or use technology to graph those 2 points like I've done here, connect them with a line, and then count to find my slope and look to find my y-intercept. So my slope here, it goes up 2 and it goes over 6. So my slope is 2/6 or 1/3 if I simplify that. My y-intercept looks like it goes right through 4. Let's just double check using that 1/3. It goes up 1 over 3. Yes, agreed. It goes right through 4. So my equation here is y equals 1/3 x plus 4. It's not always quite as easy though. It's really depending on the points. So here I have 3, 5 and -1, 3 graphed. When I connect these two, it doesn't go right through a clear point. So let's find the slope up to over 4. I can simplify that to 1/2. And then if I was guessing, I would say the y-intercept goes through about 3.5. But let's just double check. So I could go up 1 over 2, but that's not getting me to my y-intercept either. But this right here is going to be halfway in between, right? It's going to be half as big as this. So it's going to be up 1/2 over 1. And I do think if I'm going up 1/2 from 3, I am going to be landing right at 3.5. So we were able to kind of deduce that one, but we were still using the graph to figure it out. And we were not just saying, oh, it's about 3.4, right? We were using the slope to get a good estimate of where it was. More than an estimate. We can tell it's at 3.5. However, if we didn't have the graph, we can always just solve for b. So that slope we had was 1/2, and we were given these 2 points. We can always put in this slope for m and then pick a point, either point, it doesn't matter in the least, plug those in for x and y, and then find what b is. So here I can see I'm gonna have, -1/2. If I add that 1/2 to both sides, that my b was 3.5. I didn't need the graph to find that. I also didn't need the graph to find the slope. I could have used the slope formula, right? So I could have done y2 minus y1 over x2 minus x1. I've got these 2 points. It doesn't matter which one is, point number 1 and which one's point number 2. I'm just picking. I'm subtracting my y's. I'm subtracting my x's. And I end up with something that's going to simplify right down to 1/2. So I could have gotten this entire equation without using the graph at all. I can do the whole thing algebraically. It's just really going to depend on what's easiest at the time and for the given problem. Another way that we can write our equation is using point-slope form. So we don't have to use that y equals mx plus b from slope-intercept form. We can use point-slope form, which uses a point, any old point that we call x1, y1, and it uses that slope. M is still the same. So if we have 2 points, we can find the slope, subtracting my y's and subtracting my x's, and then just plug that value into my equation. So I'm going to have y minus, we'll pick a y1 in just 1 minute here, the slope 3/4 times x minus my x1 value. And now these can be either point. It does not matter in the least. I'm going to use 1/4 this time. So 1 was my x and 4 was my y. I didn't really need these boxes, right? I just put them in for my own self. And I've got my equation in point slope form and I'm done. Now, for me, I like slope-intercept form because I think it's easier to start graphing. But really, this is saying I can start at 1/4 and then use the slope 3/4 to graph it. If you would like to convert this to slope-intercept form, You can distribute out this slope and then move this value to the other side by doing our opposite operation. And we're going to have our equation in slope intercept form. So point slope and slope intercept, you can go in between them pretty easily just doing the algebra. Or of course, we could have just found that slope 3/4 and then solve for b the same way we did on the previous problem. So let's just do a little bit of practice here. You're more than welcome to just do these on your own, but I'm going to go ahead and start by finding my slope. Subtracting my x's, subtracting my y's. And then I'm going to plug that into slope intercept form just because it's my little preference. I'm going to plug in a point and solve for b. Mm-hmm. 24, 3 times 8, divided by -4. It's going to leave me -6. So my equation is y equals -3/4 x minus 3. Your equation could have been y plus 9 equals 3 times -4 times x minus 8. Note that this was y minus -9, and I changed it to plus without really explaining. Or you could have used the other point, y minus 0 is just going to be y times my slope, x minus -4 turns into plus 4. So all of those are interchangeable. These are all great options for this problem. So when we sit down to a word problem, we're going to look for what we are given here. So we've got Kaylee rides her bicycle for 3 hours and is 18 miles from her house. And that might not look like it, but that is a point right there. 3 hours and 18 miles are attached to each other. They are related. So they're going to be one of our points. After riding for 9 hours, she's 42 miles away. Now, they didn't say it, but we're assuming that she's moving at like a linear speed, no brakes, never speeding up or slowing down. Anyway, we're going to write an equation to model this situation using d for distance from her house and h for hours. So we're going to let one of these be 0.1 and the other be 0.2. We're going to find a slope and go from there. So I'm going to subtract my y's, which in this case are d for distance, and subtract my x's, which is hours. Looks like we've got 4. And if we think back to the units of this problem, distance was measured in miles and our h was hours. So this is really, since slope is always y over x, in this case d over h, this is miles per hour. So we can think in the context of this problem, does that make sense? Does Kaylee ride her bicycle 4 miles per hour? I mean, honestly, that's pretty slow on a bike, but it's not like 95 miles per hour, nor is it like 0.2 miles per hour. So, maybe Kaylee's a small child and this is reasonable. And also, not every math problem is written to be 100% reasonable. So, we're going to assume this is fine and keep going from here. So, I can now, if I'm using point slope, I can just pick one of these points and put that slope in and my x and my y values in, and I can be done. Or I can use my mx plus b, plug in one of the points, and solve for b. And either of those are going to get me a correct answer. It doesn't matter which one I do. And you probably remember, right, that we could also have just distributed out and solved this into y equals form, and we would have ended at the same equation. On we go. The coffee shop Java Jive has prices that increase linearly based on the size of the coffee. A 16-ounce coffee costs $4.45, and a 20-ounce coffee costs $5.25. So we're going to let y be the cost in dollars of an X ounce coffee. That's our size. So we're going to write an equation for this. For my slope, I'm going to do my y minus y over x minus x. Oh, I've written something wrong. 45, not 25 cents. I'm going to get 80 cents divided by 4, or this is 20 cents or 0.20 of a dollar for every 1 ounce. Okay, but that's not what we're looking for, not just the slope, but the full equation. So I can write out y equals 0.20 times x plus b, plug in one of my points and solve. So I'm going to plug in my 20 and 525 just because I wanted to, not for any other good reason. It looks like b is going to be 125, so my equation is y equals 0.20 of a dollar plus 125. Could have also written this, right, using one of your points and doing point slope form, equivalent versions.